My name is Nikhil Rajesh Kumar Tamatta, and the topic of my research paper is Interfacing Serverless Computing with DevOps for the Design and Development of Cloud Application. It's for the subject module Research in Computing. So let's begin with the presentation. Introduction. In the cloud computing world of today, the organizations are required to implement applications that are cost effective, scalable, resilient, and at least time spent on the management of the infrastructure. This paper presents the connection between DevOps processes such as CI/CD automation, which is continuous integration and continuous development, infrastructure as code and observability, and serverless computing, especially with AWS Lambda and associated AWS services. The problem I address in this research paper is that serverless computing comes with a lot of advantage such as no servers to take care, event-driven computing, and auto-scaling. However, in an attempt to implement the traditional DevOps practice, serverless does not fit into the CI/CD workflows. It tougher to do rollbacks and debugging. The unobservability and inobservability. My study endeavors to close this gap by creating a pipeline that would support DevOps friendly serverless application. Key objectives. There are four major key objectives of the research where are follows: enforce CI/CD of serverless applications via the utilization of GitHub Actions and other AWS services. AWS means Amazon Web Services. Terraform, secure and usable administration of infrastructure, and observability by using CloudWatch as a log and metrics. Provide automated rollback in the instance the release fails, such as the code deploy and Lambda aliases. Tools and services used in my research paper. First one is GitHub Actions for CI/CD orchestration, AWS Code Build to package Lambda functions, AWS Code Build, Code Deploy to manage safe development using Carnage strategies, AWS Lambda as the compute layer, Terraform to provisioning, CloudWatch for monitoring and automatic rollbacks. All tools used are public, safe, and aligned with NCI's ethical policy, no personal or sensitive data involved. Research methodology. I followed a design develop test approach, design the pipeline and architecture, develop the automation using GitHub Actions and Terraform, test deployments with simulated errors to evaluate rollbacks and observability. Result and contributions. The resulting system provide a repeatable, scalable, and fault-tolerant deployment pipeline for serverless apps. Key contribution include a reusable DevOps architecture that works with AWS serverless tool, practical observability features using CloudWatch, automated rollback to improve resilience. This architecture is in line with best practices in the industry and many by used by developers and teams that want to implement serverless without sacrificing DevOps benefits. Here is the conclusion. In this study, a solution is offered to implement serverless in the context of DevOps tools. It delivers CI/CD support in full, automation of infrastructure using Terraform, observability and rollback. In short, the project demonstrates the collaboration of DevOps and serverless in the course of secure, scalable, and reliable cloud application. Thank you.